Hi, and welcome to this webinar. I'm Michel Baudin with the Takt Group, and I will spend the next few minutes giving you my introduction to Lean. I was first exposed to it as a young engineer in Japan in 1980, a decade before the term was coined, and have been helping companies implement it professionally worldwide in many industries since 1987. I'm going to be explaining it to you in the simplest possible terms I can, without being simplistic or inaccurate. If you want to know more, you will find our contact information on the last slide. By now, you must have heard of Lean, and chances are that your company has had a Lean initiative or Lean program in place for a while, and it may or may not have been successful. In fact, most Lean programs in the US have yet to deliver the benefit that their promoters advertised. If your company is in this category, you may wonder, why bother? Isn't Lean just another flavor of the month program that has been oversold? More than the vast number of companies that have made a half-hearted or ill-conceived attempt at Lean, you need to look at a small minority that have, through their effective use of Lean, achieved dominance in their industries. Their stories will tell you why you should pursue Lean. What the other stories tell you is that you should not underestimate the challenge of implementing Lean. Driving down American roads, you are surrounded with cars made by Toyota, Honda, and Nissan, all relative newcomers to the auto industry, and even Hyundai, the latest kid on the block. And most of these foreign cars are made in the US by American workers, largely from parts also made in the US. As latecomers to a mature industry, how did these companies manage to secure positions in its top ranks? Lean is essentially the Toyota production system. The Nissan production way looks very much like it. And Honda, while fiercely independent, has also adopted much of it. What about Hyundai, the Korean conglomerate? Well, Hyundai Motors is run by John Krafcik, who coined the term lean production while involved in a worldwide benchmarking study of the auto industry. Digging further, you find that auto parts makers like Autoliv or Valeo have also thrived as a result of Lean, as have a minority of companies in industries like furniture, medical devices, electronics, or construction machinery. Synthes, now part of Johnson & Johnson, is a Swiss maker of orthopedic implants that started with Lean in 1984 and grew to dominate this industry. These are just a few examples of international companies that, through Lean, have achieved a success that commands attention. The companies that fail at Lean are runners who buy imitations of Usain Bolt's shoes in the belief that it will make them run fast. Shoes do not make a runner. A concert piano does not make a pianist. Many managers delude themselves that implementing Lean is just about deploying a few simple tools. In reality, it is a learning experience that requires practice and perseverance. It will make your company great, but it is not a shortcut. Most managers who undertake implementation of Lean misunderstand and underestimate its scope. They think it's just about involving shop floor people in tidying up their work areas, making small improvements to the workflow, and posting performance charts. A successful Lean implementation, however, starts with the manufacturing and industrial engineering of production lines, moves on to in-plant and supply chain logistics, the human organization of production and support, and the way results are measured and metrics are used in operations. As Tom Bergen put it, it's not doing feng shui on the business, it is the business. Reviewing the effect of Lean implementation in an auto parts plant after 1 year, I was surprised to find that the sales manager was the most enthusiastic supporter. Before, he said, when a customer requested sample production of a new product, manufacturing was always too busy with late orders. I'm not sure what you guys have done, but now they turn around the sample in a few days and the customers follow up with big contracts. Our sales are up 50% from last year. Salespeople exaggerate, so it was probably more like 25% up than 50% up. But still, the fact was clear that what we had done in production and support was enabling growth. Incidentally, the Lean effort was also reducing costs, but that was a desirable side effect, not the goal. Every day, many managers play manufacturing whack-a-mole. They start campaigns to improve one dimension of plant performance without realizing that these campaigns will hurt other dimensions. Other campaigns then follow to undo the damage done by the first one. But they undo the improvements as well. Quality, cost, delivery, safety, and morale, collectively referred to as QCDSM, are the most commonly measured dimensions of manufacturing performance. In any plant, performance in any one of these areas can easily be improved at the expense of others. More stringent inspections will enhance quality, but also increase costs and lengthen lead times. Cost reductions by suppressing free coffee, rationing copies, delaying maintenance, and cutting budgets by 10% across the board hurt performance in every other way. Delivery improvements can be pursued by building stocks, thereby increasing costs and delaying the detection of quality problems. Safety can and sometimes must be improved by restricting what operators do. Safety improvements are often explicitly perceived by management as driving up costs and slowing production. Morale can be boosted by various campaigns to show concerns for employees. For example, by promoting employee education. Actions that are not directly related to the work, however, have at best a temporary effect and add cost. Can we improve any aspect of manufacturing without making something else worse? The answer is yes, and this endeavor is in fact at the heart of lean manufacturing. I like to define lean manufacturing as a pursuit, meaning it has no end state. It is something you always work towards. And it is the pursuit of concurrent improvement in all dimensions of manufacturing performance, meaning the end of management whack-a-mole. Improving anything by making something else worse is simply not improving at all. And a genuine improvement is only feasible by addressing all dimensions of operations: engineering, logistics, organization, and accountability. How does it work? The elimination of overproduction reduces cost, but also improves quality because it prevents problems being buried in WIP. And it makes nothing else worse. That's why we call overproduction waste. Likewise, reductions in waiting not only reduce costs, but also have positive side effects. Active operators are less bored and more alert than those who are waiting, and more likely to react effectively to danger and therefore safer. In addition, management's unwillingness to waste their time tells them they are valued and makes them feel more secure in their jobs, which enhances morale. The projects on the left of this slide are the means of achieving waste reduction. Walking around the shop floor with a clipboard and writing up cases of waste doesn't work. Instead, a structured array of projects transform the physical shop floor and the way people work. The willingness to move and modify machines are needed to facilitate the flow of materials, and the movements of people sets lean apart from other improvement efforts. Assuming that machines cannot be moved and only addressing information flows, usually by laying a computer system on top of the current shop floor layout, will not achieve the results of lean. Where did this all come from? TPS did not arise in a vacuum. Its creators actively sought knowledge and ideas from abroad, but as the timeline shows, primarily in early days. TPS is still a work in progress. It has been, and still is, primarily an original development. The main outside contributions date back 60 years and more. The bulk of TPS has come from the minds of inventor Sakichi Toyoda, his son Kiichiro, engineers Taiichi Ono and Shigeo Shingo, and hundreds of thousands of Toyota employees over decades. A trade secret until Toyota started training suppliers in the 1970s, TPS has been a source of ideas for others since the publication of Taiichi Ono's book in 1978. The American influence, particularly Ford's, is readily acknowledged and played up in Toyota's official literature. The U.S. is Toyota's largest export market, and emphasizing the American origin of many TPS concepts is useful in diffusing nationalism. The German contribution, on the other hand, is in small print. It took place at a dark time for both Japan and Germany, but takt is a central concept in TPS, and it came to Toyota from German aircraft manufacturer Junkers via the Mitsubishi aircraft plant in Nagoya. Toyota also learned automotive technology by reverse engineering a 1936 German car, and its first post-war model, the 1947 SA, looked like a Volkswagen Beetle. What are the tools of lean? In engineering, these shots from different industries show examples of changes made to a shop as part of lean, ranging from line layout, as in the back sewing cell, to details of single operations, like standard work instructions in auto parts, quick changeovers in plastics extrusion, visual storage for aerospace fixtures, or mistake proofing in car engine assembly. Logistics covers all the routine operations of a plant except production, and some of the best-known lean tools in this area, including in-plant milk runs, using small trains to deliver parts and kits at a regular pitch from storage to production, carts, designed to hold kits of parts and sometimes double as assembly fixtures, the Kanban system with cards regulating and sequencing a line, and supplier milk runs, with trucks making the rounds of suppliers, delivering empty containers and picking up matching quantities of many items along the way. In the organization designed to support Lean, you do not have a high-level manager in charge of all machining and a different one in charge of all assembly. In a Lean plant, you have instead managers in charge of product lines with control over all the resources that can be dedicated. On the floor, going Lean does not mean gutting supervision. Quite the contrary. First-line managers have fewer reports than in traditional organizations and devote part of their time to leading improvements and planning the careers of their people. Production itself is organized in small teams of multi-skilled operators, each led by its most experienced member. Support groups for maintenance, quality, engineering, or human resources are also set up differently and have different missions. Performance charts posted on the floor are updated and reviewed at the start of every shift to provide immediate feedback on results and keep employees engaged. The template you see has a column for each dimension of performance and rows for current status, an aggregate historical trend, a breakdown of the aggregate into categories, and a list of actions in progress. There are many other tools, but what is the philosophy behind them? Lean was developed for making cars, and many of its tools are not directly applicable to electronics, aerospace, furniture, cosmetics, or hospital operations. Adapting these tools to a different context is rarely straightforward. It often requires extracting underlying principles from specific tools and then applying these principles in different ways. But what are these principles? The Toyota people were too busy developing and deploying their own system to stop and articulate its principles to a usable level for the benefit of outsiders. Different consultants have come up with different lists of principles. This one is intended to be high-level and generic, yet actionable. Focusing on people is not about coddling them, but about making full use of what makes them unique, particularly their ability to observe, think, solve problems, and create. In manufacturing, production operators are drivers racing to the finish line, and the rest of the organization is their pit crew, and this should be reflected in the attention given to operator job design as well as in the attitudes of support staff members. Some tasks are done frequently, others rarely. Find out what it is that you do the most often and make it easy to do. Avoid one-size-fits-all approaches that make you do all tasks the same way, regardless of frequency. Most work processes involve multiple operations. Making the work flow means designing it so that the output of an operation immediately enters the next one. It cannot always be achieved, but it should always be pursued. Finally, you should never think that you have optimized anything, because by definition it would mean the end of improvement. Never best, always better is a slogan Mark Graben noticed at Toyota in San Antonio, Texas. However you do your work today, there is always a better way. You should seek it, and this quest should never end. Lean is a rich subject. This is an elevator pitch for it. I could go on for a week. What is visible when you visit a Lean plant is more detailed than what I covered today, but still a small part of a technical and managerial substance that you cannot see unless you live long enough with the organization. Then you realize that beyond practices, the competitive strength of a Lean organization is based on behaviors and beliefs shared by members at all levels and transmitted to new members. In other words, it's a culture. If you would like more information about what we do and the services we offer, do not hesitate to contact us. Thank you for your attention. We wish you the best success in your implementation of Lean.